Okay, for question number 5, we know it's an analyze combustion problem. So it has given us the analysis of 0.513 grams of compound, and for the MgS04, it has a mass of 56.784 grams. And after the experiment, MgS04 has become hydrated to a mass of 58.887 grams. We know MgS04 is dehydrating. And so what I did was find the mass weight of H2O by subtracting the after experiment to the before experiment. And that's how I got my answer, which is 56.887 grams, subtract 56.784 grams equals to 0.103 grams of H2O. And so it also stated that similarly, the mass of NaOH has increased 34.302 grams from 33.801 grams. And so I did the same exact thing again as finding for the CO2, the carbons, which I subtracted by the before and after again, which is 34.302 grams, subtract 33.801 gram, which gives me my answer 0.501 gram of CO2. And so going down, we want since we got the gram of H2O and CO2, I want to find my grams of carbon only. So I started with my mass of CO2, which is 0.501 grams of CO2, and we divide that by the mass of CO2, which is 44.01 grams of CO2, into 1 mole of CO2. And going down, we do 1 mole of CO2 again to 1 mole of C. To 1 mole of C is C, the mass is 12.01 grams of C. So what I did was multiply the whole entire top and divide by 44.01, and it gives me my answer to 0.1367 grams of carbon. I did the same thing for H2O. I start out with 0.103 grams of H2O, divide that by the mass of H2O, which is 18.016 grams of H2O, to 1 mole of H2O, to 1 mole H2O equals to 2 moles of H2O, to 1 mole of H equals to the mass of H is 1.008 grams of H. And doing the same thing again, 0.103 grams H2O times 2 and times 1.008 divided by 18.016. I get the answer 0.01153 grams of hydrogen H. So now we find the oxygen. We know that the analysis of 0.513 gram 0.513 gram of compound, we know that is the sample. So what I did was subtracted to the grams of carbon and the grams of oxygen. By subtracting all of them, I get 0.365 grams of oxygen. So now that so since we got R of a gram of oxygen, we want to convert them back to moles of C, H, and O. So by doing that, I convert the grams. So I start out with for the carbon is 0.1367 grams of carbon to the mass of carbon, which is 12.01, and divide by both of that, I get the answer of 0.0114 grams of carbon. And then hydrogen, I did the same things. I start out with the grams of hydrogen, which is 0.01153 grams of hydrogen, and I divided by the mass of H, which is 1.00 grams of hydrogen to 1 mole. And by dividing both of them, I also get 0.0114 grams of H. And for oxygen, I did the exact same thing too again. I start out with the gram of oxygen, which is 0.365 grams of oxygen, to the gram of oxygen is 16 grams of oxygen to 1 mole. Divided by those two together, I get 0.0228 grams of oxygen. Then I will want to divide by the lowest number. I divide by the lowest number, which is 0.0114 gram of carbon and H. So since we know both of these are the same, we know it's going to be equal to 1. And when I divide 0.022 gram of oxygen to 0.0114, I get 2. And when I add all the mass up together, I get 45.018 grams of mole, which is not nearly as close as to 90 grams of mole. So we know that. So we would divide by the gram of mole, which is 90 grams per mole, divided by the gram of moles of what we got here, to 45.018 grams of mole, and I get 1.9, and I'll round it up to 2. And when we get 2, we basically just multiply everything back to the formula, the compound formula, which is CHO2. Well, and that's how I got my empirical formula right here too. And then since I'm trying to look for the molecular formula, I just multiply everything together. And by multiplying everything together, I get the molecular formula of C2H2O4. And that is the answer for the molecular formula for this problem.